So what happens to those operators that don't work from left to right? They work from right to left. I hope I said that right. There are several of those, like unary, power, a not symbol, a bitwise complement. There's a bunch of these that actually work from starting on the right-hand side and moving to the left-hand side. And here's a perfect example of doing just that. So especially with power and stuff like that, we'd have to worry about taking care of the right-hand side first and then multiplying it to the left-hand side. So it's going to be very similar to what we had in the previous one. We're going to use recursion. This time, it's going to call itself. We know that part. But this time, which side do we need to actually have taken care of first? It's going to be on the right-hand side. So you're going to see the right hand call itself from that operator in order to make sure that its lower hanging fruit on the tree and will be taken care of. So in the left recursion that you just saw previously this video is that we made the left-hand side take care of itself because it's literally going to be heavier and lower on the tree. But when we need to do right recursion, because the associativity is backwards, we're just going to do the opposite. We're going to make sure the right-hand side of that equation is actually going to be further down and taken care of first in the tree. So that's how that's going to work out in theory. So this is how it's going to look like when we set things up. Now again, notice here's the left recursion. It was physically on the left because we're going to recursively call this an expression. The left-hand side tree was going to expand. We're just going to do the opposite when it comes to, again, very specific operators to handle right to left instead. We'll just make sure it's on the right-hand side of the actual physical operator in order to make sure that that side of the tree is going to be heavier than the other side. And again, that right-hand side is going to be heavier and, well, further down the tree, so again, to make sure it gets precedence over the other side.